Hello everybody, I will start my today with another live coding session. In my today's video, I will solve this question. Guess the word. So in this question, I'm giving an array of unique strings words, and each word is 6 letters long. One word of the words was chosen as a secret word. You are also given the helper object master. You may call master.guess word, where word is a 6-letter long string, and it must be from words. Master.guessWord returns -1 if word is not from the words, or an integer representing the number of the exact matches, value, and position of your guess to the secret word. There is a parameter, allowed guess, for each test case, where allowed guesses is the maximum number of times you can call master.guessWord. For each test case, you should call master.guess with the secret word without exceeding the maximum number of allowed guesses. You will get either you took too many guesses or you didn't find the secret word if you called master.guess more than allowed guesses times, or if you didn't call master.guess with the secret word. Either you took too many guesses or you didn't find the secret word. If you called mastered guess more than allowed guess times, or if you didn't call mastered.guess with the secret word, or you guessed the secret word correctly if you called master.guess with the secret word with the number of calls to master.guess less than or equal to allowed guesses. The test cases are generated such that you can guess the secret word with reasonable strategy, other than using the brute force method. Okay. So in this question, I'm given the word list, and each word is 6 letters long. Yeah. The ranks of the word list should be 1 to 100. Okay. And also I'm given the one word. No. And I'm also given the object master, which I can use to call master.guessWord. Yeah. And my task is to find the secret word inside of the word list. And I can use master.guessWord to check if that word is the secret word or not. And if I call master.guess more than allowed guess times, or if you didn't call master.guess with the secret word, or you guessed the secret word correctly, if you called master.guess with the secret word with the number of calls to master.guess less than or equal to allowed guesses. I see. So I can call master.guess as many as possible in the function find the secret word, and it has to guess the correct word, yeah, at least once. Or I see, I understood. So I don't have to take care if master.guess were I could call this master.guess with the correct secret word or not in my implementation, but I just have to keep going. And out of the limitation, maximum number of calls, the limitation, if I could call master.guess with a secret, it's fine. If not, it fails. Yeah. Okay. So basically, yeah, that's the thing. Okay. Hmm? For each system. If I didn't call master.guess with the secret word, I think this is end. Because if I mean, I call master guess with, yeah, this is quite confusing. But yeah, basically master.guess returns an integer and it should be number of exact matches. Yeah. Based on that, I can filter the secret word candidate from the words list, and I can try again and again and again. That's my understanding. Okay. So let me think with an example. So let's say I'm given like let me think with 3 charts example, not the 6 charts for now. And the secret is I would say AAB. In that case, for example, if I call master.guess with AAA, they should return 2 because there are 2 A's which are exactly, I mean, the first 2 A's are exactly matches the first A's in the secret, but the last A doesn't match because it's B in the secret. And if I call AAB, they should return 2. And if I call ABB, it should return 2. Yes. Oh, this should return 3. Yeah. But I can keep calling master.guess as long as I don't exceed the maximum limit, maximum number of calls limit. And that should be, checked in the, you know, test executor after I submit it. So I don't have to take care that much. For example, in this case, this should return 1. And basically, based on these results, I have to filter out the possible words in the words list. Yeah. So if I call AAA and if I get 2, I can filter the word which are I can leave only these, words. And sharp cannot be A. And sharp cannot be B. And sharp cannot be A. I have to filter out these chairs in the verse list, and those are remaining. The remainings are so AAB, or the one which applies to this AA sharp, not A, is AAB or AAC or something, right? So it should be AAB only. And AA or ACA or ADA, it can be AAA. No, this cannot be A. So AAA can't be, but ABA can be. Yeah, let's include it. And also I would get something AA, BAA or CAA or something like that. I can include BAA, which doesn't exist. Let's include it. Yeah. And these are possible remaining chars. And out of these words, I will pick one word. So let's say I choose ABA. In this case, this should be now ABA. So this should be 1. Yep. So candidates are now sharp BA, not A, or A sharp A, or A asterisk A, not B, or AB something, not A. So remainings are so for this one, something BA, like BBA or CBA, doesn't exist. And for this one, AAA or ACA, but it doesn't exist. And AB something, ABB or ABC or ABD, it doesn't exist. Oh, wait a minute. But AAB should be fine. If I call with ABA, it should be 1. So it should be. Okay. So this should be 1. So it can be something something B, A something something, or something B something, or something something A. And the first one cannot be, sorry, second char cannot be B, second char cannot be A. And for this, second char cannot be B, so A. Third char cannot be A. Yep. And for this one, oh, I will speed up. So this can be A, this can't be B. So I can filter out that the remaining things are only AAB is fine. Yes, ABA is not fine because it doesn't apply to this. Yep. Wait, I'm quite confused. So for this one, something something A. Yeah, but basically something like this. Yeah. Basically, in that way, I can filter out the words BAA can be an option, and then I would say I would choose AAB, and now I guess the 3, and BAA should be filtered out, and it's that way. Basically, this is the approach I can take, which is quite basic, I think. Or I should say, the brute force approach should be try out each word and hope that every, the master that guess is code unless the maximum limited time. But probably it doesn't work because I don't need any smart, reasonable strategy. There will be some cases that it doesn't work. So I will filter out the words. So for the brute force approach, try each word one by one. And for the what it not the brute force approach, but optimized approach, I'd say where's pool? And definitely I will try for each word in the pool call mustard gas and filters the words pool and removes the invalid words. Then I will try again. And I will keep going until the pool becomes only one single character. But I don't have to care of the ending. I mean, even if the pool has only one word, I don't have to finish the iteration because I can call that many times as I want. Just the test executor handles that case. Say, even if I find the answer secret word in 5 times, the allowed maximum time is 10. In that case, I just have to call 5 more times with the secret word. It's completely fine. So this is the approach I can take. Yep. And probably I think how I should choose this word from the word pool. That is the key. Yeah. The first optimization is how to choose this word. That is the key. But let me write the solution first and think of this part later. I'd like to code the working solution first before thinking of the optimization. Yeah. So for now, okay. Yeah. So yeah, okay. Every time I pop up the word, if it is the secret, then every other word should be pop deleted. If this is not the secret, this word should be pop, not be remain where this will not, you know, keep stored in the pool. So what I mean to say is in this way, I can choose the pool, sorry, I can choose the word, which is every time different until I find the secret word here. So this is a match count. So what I would do is so this will return the boolean. And what I can say is so I will create a new pool or yeah. Okay. In this way, I confirm this may be the secret word or not. Then if this may be the secret word, then I put it in the pool. In this way, this pool is reinitiated and I will make it the, yeah. Sorry, I actually don't make it a, set. Just the list is fine. In this way, new pool list is initiated and I will use it. Yep. Okay, so this is how it works. Let me rename it candidate words. I think this is more readable. Okay, and I will implement the maybe secret, or I should say, is secret candidate. I think this is more easy to understand. Yeah. Okay, so now I will implement the is secret candidate method. So given the guess word and match count, I will check if the word is can be the secret candidate or not. Obviously, what I can do is actual count. In this way, I will count the actual match count. Actual match count. Guess word. Wait, this is match count. Expected match word. Yeah, let me call it expected match word. And I will count actual match count here. Okay, so this is how I can check if the given word can be the secret candidate. If it is the secret candidate, the match count should be exactly the same as expected one. So I checked it. Good. Okay, so let me check my code again. So here in line 43, I initiate the list of the words. This is the candidate, and I will keep doing the guess. So I do the infinite loop in line 45, and I choose one word from the candidate words, and which is named as guess word. And I will check how many match counts there are in the guess word. And with that, oh, this will not be pool anymore. I reinitiate the candidate words. I basically filter the words and leave only the candidate words. So that's what I do here. Okay. And in line 55, I implemented is secret candidate method. So I compare how many words, how many match counts there are for the given word with the expected match, guess word. That's correct? Wait, let me check. If secret is AAA and guess word is, let me make it ABC. If the guess word is AXC, then expected match count should be, what is expected match count? Yeah. So expected match count should be 2. Okay, so if the word is exactly the secret word, then the match count of the word and guess word should be expected match count. Yes. If it is true, this word can be the candidate. But if not, this word is definitely not the secret word. Okay, yeah. I think it now makes sense. Okay, now let me execute my code. Okay, I have to put self here. And this should be equal equal. Oh, it seems like even the secret word is popped out, I guess. Let me print out what are in the candidate words. Here, and okay, if guess word is the candidate word, sorry, secret word, in that case, it should return exactly 6. And expected match count is 6. Okay, sorry, I mean, so it seems like if the candidate word is only the secret word, the candidate word list becomes empty after the filtering. And guess word here, so I will check what happens if candidate word is like this. In this case, guess word is like this, and match count should be, it should return 6. So what happens is that this method is called with where there's the secret word and guess word is the secret word and expected answer is 6. And yes, this should be true. So I think this candidate word should be remaining. But seems like it's not true. Okay, so let me check what is returned if 6 is rarely returned. Yes, 6 is returned. And I will check what is returned here. So 6 is returned. Wait. So candidate word is now only the secret word. In that case, guess word is now candidate words.pop. And match count should be 6. But seems like this is secret candidate is not called. Oh, I see. Because guess word is already popped out. That's the problem. Okay. What I can do is I just have to choose the first word. Yeah. And I will use it the guess word. And if this is the secret, this first word remains and the candidate word is has only single element, secret word, and it keeps going with that. And if this guess word is not a secret word, this guess word should be popped out from the candidate words. Yeah, so it's okay. Good. Okay. Oh, time limit exceeded. Let me check what is remaining every time in the while loop. Wait, I think master the guess is called with the ACCKZZ, but there it doesn't say I guess the correct word. What should I do? Maybe if match count is 6, I have to break. I don't know. Let me try. Okay, yeah, I have to break by myself. So. Okay, so now I will submit my code. No. Okay, so I took too many guesses or I didn't find the secret word. So I have to think of the better algorithm. So the optimization we can make here in line 26 is I have to choose the word which can filter the word as much as possible. So for example, if I have say A, B, A, and A, B, and A, B, 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 A, I don't know, A, and say if I choose, if I have X, 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 in that case, if I choose this, and if it returns, say, 3, in that case, what happens is that, oh no, if this returns like, one more. If this returns 0, I can just filter this X, 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 X. I cannot filter anything from here. But if I choose this and say if I get 2 or something, in that case, I can filter more words. I can remove more words from this remaining pool. I should say candidate words. So I should choose the kind of popular word or, kind of average word from the words candidate list. So that's what I can, include in my logic. So what I can say is, in this case, for the first character, A is quite famous. For the second character, A and B are famous. Third, A and B. Fourth, A and B. Actually, A and B are quite famous. So I will count how many times A appeared for each first character. And then I will calculate the frequency of each character in the second character. And then for each character, I will think of the point. So if I have A, and the first chair is A, and if there in total 4 A as the first character, this A gets 4 points. And for this one, because there are 2 A's as the second character, this A gets 2 points. So in that way, for each character in each string, it gets more scores if the same character appears in the same position in the given strings. In the candidate words. In that way, I calculate the score for each string, and I will, and the word with the highest score should be the next guess word. So that's the approach I can take. Okay. I don't know how to code this, but let me call it choose average word. Okay, so now we'll implement this. So as I said, frequency, child frequency map for each score, so each chart position, and then calculate score for each word, then return word of highest score. That's what I can do. Okay, now we'll implement this. So okay, in this way, I could build the frequency map. So now what I will do next is so here I will keep track of the highest score and also returned. That string. String returned, return string. So if there is a tie, I can return anything. So I will not update the return string. So for here, the score can be calculated as let me write the for loop. Okay. Okay, now I've got the score. So if this score is higher than the highest score, return string is updated. And I will return this string instead. No, return string. Or I should call it returned word. Okay. So I have 2 minutes, more minutes, but I would like to do the complex analysis. So I don't walk through my code. I just quickly check my code. Frequency, I guess a frequency map, which is a list of rank 6, and each is a default dict of chart to frequency. And for then, what we do is firstly complete the, builds the frequency list. So for each word, for each index, I append the char to the frequency map count. Then I iterate the word again, and in this second pass, I will calculate the score of each word. Then, if that score is higher than the current highest score, then I update the return score, and also I update the highest score, obviously. Okay, so now I will execute my code again. Good, accepted. Okay, accepted, great. So I will quickly do the complex analysis for this optimized approach. For time complexity, assuming that there are n words in the words list, the time complexity should be I see. It's quite hard how much I can filter the word. So let me focus on the time complexity of this part. Choose average word. Yeah. Okay. So, and also it depends on the remaining number of words in the word candidate words. So basically, I can't completely say how many words are remaining. It totally depends on the distribution of the words in the words list. Okay. But at least what I can say is here, time complexity should be assuming there are n words. So 6 times n to build the frequency map and list of the frequency map. And for this part, in the second pass, I iterate each word, there are n words, and I take a look at each chart to update the score, so there are 6 times n. So it should be O of n time for this choose average word method. For space complexity, this should be for highest score list, there are 6 slots, and for each, there can be up to 26 characters, 26 unique character, because each word can consist of only lowercase English letters. So A to Z, yeah. This should be constant. So that being said, for space complexity, I'm pretty sure this should be O of n. The only data structure I use, which is non-constant, is now candidate words, which includes up to n words. So n times 6, which is n. Okay. For time complexity, it totally depends. But assuming that I can filter n to n1 to n2 to them 1, then the time complexity should be the sum of them. Yeah. Because once I choose the guess word, which takes remaining number of words, which takes the time proportional to the number of remaining words, much count operation. Let me ignore this, but probably this should be O of n. And here, I'm filtering the word, but this takes only the constant time because I'm just checking 6 characters in the given word and guess word. Yeah. And as you can see, I'm doing the for loop for candidate words, which is length nx. So yeah, this should be sum of nx. Okay, so that being said, I quickly wrap up my today's coding practice. So today I solved the question, guess the word. And in this question, I'm given the list of the words, and my task is to find the secret word. And I can code the master.guess to check if the guess word is how much close to the secret word. It returns the number of exact match charts count. Yeah. And in my solution, basically, I guess the word one by one. And based on the result, the match count of the guess word, I filter the candidate words and I try again and again. And one optimization I made was that I chose the kind of average word when choosing a guess word from the remaining candidate words. So average word means that for each chair in the word, if there are many strings which has the exact same chair as the exact same position, then that word is, I can say, more like the average. Yeah, so that's how I choose the average word. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.